In WaltR, we have developed and commercialized two data as a service emission tracking services. The global emission tracker that is based on Sentinel-5P data and provide the 500-meter gridded monthly emission flux maps of NO2, NOx, and SO2 from NOEMI L2 that answer the need of our finance customers at the moment, such as bank, insurances, asset management, and rating companies. Other air quality and greenhouse components are currently under development to complete the service. VOX, NH3, PM1, PM2.5 as an example. And moreover, we have the second service is the local emission tracker based on our in-house ground multi-hyper spectral imagery that acts as a local zoom of the global emission tracker service to target smaller space frame and shorter time frame. Local emission tracker go-to-market initially has been done with airports. We systematically and automatically monitor the APU's auxiliary power units use duration and their associated emissions on CO2 and NOx in real time. In addition to emission levels, our customers are increasingly asking for high-resolution maps of pollutants concentration. 100 meters every hour is a common request, I would say, from different segments of the market that are involved to emissions monitoring, emissions tracking. This is basically what drives the main objectives of the NOEMI project. The NOEMI project aims to propose an affordable, it's a commercial service, so an affordable gap filler between Sentinel-5P and NOEMI satellites and local in situ measurements to provide hourly maps of near-surface NO2 and NOx concentrations at 100-meter resolution at the regional scale. Also demonstrating that NO2 and NO fields are consistent with the so-called indicative measurements uncertainty level of air quality directives by the EU. With NOEMI, our set goal was to improve and produce hourly maps of near-surface NO2 and NO concentrations at 100-meter resolution, regulatory grade data, and as I said, the commercial service should be affordable, so affordability is a key indicator for us, and increase the cost efficiency and the automatization and the effectiveness of such data provision. Using and testing the tools that AI4Copernicus project and DIAS platforms offer, our goal is to use existing tools and methodologies to avoid double effort, automatize further our own procedures, unify and integrate the work that is performed within the European Earth observation ecosystem, and of course provide a feedback to the ecosystem and the institutions, service providers on our needs as users, as well as suggestions for improvements.
As part of this project, we decided to take the Île-de-France region in France as a study area. According to Air Paris, in 2021, around 60,000 people are potentially exposed to exceeding the annual limit value in the dense heart of Île-de-France. This region is interesting to study, since it contains a large city, Paris, as well as smaller one, but also forest, which allow for a diversity of surfaces. The region chosen cannot be too large to begin with, since to go to 100 meters, this means more than 1,500,000 points per variable, which begins to represent a large volume of data to process. S5P2 provides the NO2 concentration over the total tropospheric column, with a spatial resolution of 5.5 for 3.5 km once a day. To move to a spatial resolution of 100 meters and an hourly temporal resolution, the use of additional data and machine learning is essential. Spatial and spatiotemporal data related to NO2 are used. In addition to the S5P data, among the variables used, we can cite topography, population density, road data, emission sources, but also weather such as temperature, wind, etc. Some of this data is on a global or European scale and can be extracted from Wikio. Others are local data. All these data are at different spatial and temporal resolution. It is therefore necessary to homogenize everything. Once all the data has been processed, homogenized, and normalized, they are ready to be input to the machine learning model. That data are split into a training set and a validation set. The training is launched using the extreme gradient boosting model, which, thanks to its processing in several blocks, makes it possible to quickly process a very large volume of data. The model is then validated using the test dataset. We thus obtain the NO2 concentration at ground level at 100 meters. Fixation allows us to validate our model. Other validation will be performed in next step extensively as part of James Elizabeth's project, running at this point covering Europe and part of the world. Results and methodologies developed in NOEMI serve our baseline for many other services that are developed here.
To test every aspect and to really find the capabilities that existing tools can provide us, and also to see our limits. During the development of the NOEMI project, the team expanded, I would say, to include like machine learning, physicists, IT, and business also specialists, as it was demanding. But this gave us also the ability to have like better results and high promising results, I would say.